They are soluble, right? So we have 2 soluble salts in water. We have another solution therefore. And we want the molar concentration of the cations. When these problems are given to you, you have to be really careful. Read the problem very carefully because it might tell you that the total concentration of anions or the total concentration of cations, or it might tell you the total concentration of ions all together, right? So you have to be careful not to miss the wording and you do the wrong thing, right? Okay. Well, what do you have? You have whatever, you write down whatever you have. You have 0.20 moles per liter molarity of sodium chloride. And you also have, same thing, 0.20 moles per liter molarity of potassium carbonate. You have these 2 things. And you want to find out molarity of, molar concentration, molarity of cations. So you will have to figure out how many moles per liter in the same solution, right? These are, remember, these are in the same solution. Like that. And waves, storming. Right? Okay, so we want to find out, let's say this is 1 liter. Let's assume it's 1 liter, make things easy, right? So let's say this is 1 liter. And it has these things. So it's moles per liter. So in this liter we have 0.20 moles of this and 0.20 moles of these formula units, right? Not molecules, right? Formula units. That's what it would mean. So I make 0.2 moles of formula units in this liter and 0.20 moles of formula units in this liter. I want to find out the molar concentration, molarity in other words, right? Molar concentration, molarity, that means moles per liter. Moles of what? Of cations, right? Okay. That's how we're going to find out. So we have to go to cations. So we have to dissociate this, right? There are already ions there. Remember that? They're already ions. They don't have to ionize. They don't have to ionize. They're already ions, but when they go into water, they're in the form of ions. So from each one of these, then, what do we have? Let's see. From this one, right? When you have sodium chloride, right? When it goes to water, it dissociates to sodium plus Cl minus, right? We don't want to waste time to write too many things. I mean, you can, the correct thing will be to put sodium, solid here and aqueous here. I'll say what the correct way of doing it, but to save time, we don't really need to put these things down here. It's not important. It depends what we are doing, what we want to illustrate, how we write, right? So this equation is telling us, because some students have difficulty with this, from what office hours are showing. So you take the chemical formula of the salt, and you can dissociate it, and you can see that per one formula unit gives you 1 cation, 1 anion. In this case, we just care only about the cations, right? And should be balanced. It's balanced, right? It's balanced. Should be balanced. So 1 formula unit gives you 1 cation. The ratio of particles, whatever they are, is also a ratio of moles. And therefore, 1 mole of this, right? So I can say 1 formula unit of this will give you 1 cation. And the same thing, because the ratio of particles is the ratio of moles, I can say 1 mole of these formula units, 1 mole of these formula units, I mean 6.02 times 23 formula units of that salt, right? Will give you 1 mole, because the ratios are equal. 1 mole of sodium plus cation, right? Okay, so from 1 mole, you get 1 mole. If it's per liter, right? When we have 0.2 moles per liter of this, 0.2, right? 0.2 moles of this. How many are you going to get? If it's 1 to 1, you will get 0.2, right? 0.2 moles of sodium plus. That's it. All right? You understand this? Okay? If you understand this, we can do the other one faster, right? So we take the other one, and we have potassium 2, CO3, potassium carbonate, which is what? How much is that? 0.20 moles per liter. So if you do exactly the same thing here, you don't have to do the whole thing now, right? That will give you how many cations? Because it has to be balanced, right? This should be 2 potassium plus carbonate. Now this is balanced, right? So one formula unit gives you 2 cations. So 0.2, that will give you twice as much. That will give you how many? 0.40, right? Isn't it? 0.40 moles per liter of this, right? Okay, so from this salt we have 0.2 moles of sodium plus. From this we have 0.40 moles of this type of cations, right? We have 0.2 moles per liter of sodium plus, and we have 0.4 moles per liter of potassium plus. We want the total number of moles per liter, the total mole concentration of cations. So that will be, the sum of them will be 0.6 moles per liter of cations. Right? That's it. Yes. Capital M means moles per liter, molarity. Yes, moles. Moles, when you have 0.2 moles per liter, then you will also have same of this and twice as much as that, right? If it confuses you, you can consider 1 liter and you work with moles, right? Well, if it's, yeah, this is concentration, moles per liters. If the problem is, it could be different ways. The problem could be different ways. Okay, it's just make sure that you go along what the problem is asking, what is giving you, right?